Today we're going to look at 4.6, which is rectilinear motion. We will go in more detail on this in Chapter 5 once we learn the antiderivative. But today we're going to talk about particles and how particles move. So a particle that can move in either direction along a coordinate system or a coordinate line is said to be in rectilinear motion. In Calc 1, we only ever really deal with one variable. In Calc 3, you could look at two variables. So my particle can only move in one plane, if that makes sense, on one line. It can go up, it can go down, or it can only go up or down. It can't go up or down or left and right. Right? So in real life, we have three-dimensional, right? Three-dimensional calculus, multiple variable calculus, that's Calc 3. So for the purpose of introducing this, we're going to say, okay, if I have a particle, it can only ever move forward or backwards. It can't go also up and down. So if I want to talk about the total distance traveled, I'm only going to look in that linearly, which makes the calculus doable. In Calc 3, you'll learn multiple variable calculus, so you might be able to move along the x-axis and also on the y-axis. So that involves a little bit higher level. So rectilinear motion, we're going to look at, your book gives names to functions. So if I call s of t, that's a position function. V of t is a velocity function. Make sure I'm going through using the absolute value of V of t is a speed function. A of t is acceleration. Get these in the right order. So all these functions are related to each other. Turns out if I differentiate position with respect to time, I get acceleration. Sorry, velocity. The derivative of position over time is velocity. The change in position over time is velocity. You guys remember when we talked a little bit about instantaneous rate of change and the slope of the tangent line and the slope of the secant line? That was kind of the idea of, if I change the derivative at an instant in time, it's going to be that velocity at that instant in time. The derivative of velocity is acceleration, which would be the second derivative of position. So some other concepts to talk about is total distance traveled versus displacement. So let's look at displacement first. Displacement is the one you were probably most natural to, or the one you've seen before. Displacement is going to be, so let's say the displacement from T0 to T1. That's going to be S of T1 minus S of T0. Right? If I want to say, what was the particle's displacement, say I'm a particle and I'm on this line, and I move to the door, and I turn around and I move back. What was my total displacement?
Nothing.
0, right? But what was my total distance traveled to the door and back? So let's say the door is 5 meters. My total distance traveled would be 10 meters. So if I'm looking at positions this way, when I turn around on position, I change direction, right? That has to be a critical point of my velocity, because velocity has both speed and direction. So, let's see what I have here. The velocity function has both speed and direction. So I'm only going to turn around in my position when my velocity changes signs, right? So displacement is pretty straightforward. Total distance traveled the total distance is going to be let's call it T of C. Yeah, sorry. So the total distance traveled, first you have to check to see if the velocity equals 0 on the interval. So let's just say we found a point in the interval in which velocity equals 0, T of C. The total distance traveled is going to be the absolute value of S at TC minus S at T naught plus the absolute value of S at T1 minus S at TC. And I think in some examples this is going to make sense. So my velocity is 0, so I could have a potential of changing velocities, right, or changing directions. Because the negative tells you direction. There's direction and magnitude. So the number is the magnitude, and plus or minus is the direction. So I can only go 2 ways. So if this is positive, if this is my origin, this is position equals 0, I'm going a positive velocity. I have a positive slope. When I turn around, I have a negative slope. So the total distance traveled, I'm going to say, what was the distance traveled before I hit 0? What was the distance traveled after the velocity was 0? And I'm going to add those two together. And I take the absolute value of that. Because distance can never be negative. Right? Question?
Is that, you're just kind of explaining with that on the right, is that initial velocity equals 0 underneath the interval? It says,
Here?
yeah.
This is not initial, it's just some C value.
Oh,
So,
okay.
so let's say TC is an element of this interval. And maybe I didn't use the best subscript. TC, thank you. TC. TC is an element of it where the velocity is 0. So if velocity equals 0 in this point, in this interval sometimes, this is how I find total distance. If velocity never equals 0, my total distance is the same as my displacement. And I think once we do some examples of this, it will start clicking. So we have position, velocity, speed, and acceleration, total distance, and now we're going to look at when a particle is speeding up and when's a particle slowing down. So
Why do you subtract?
the change, because I take the, so do you understand why I subtract in displacement?
Yeah.
So it's the same thing. This is the displacement between T0 and TC. And this is the displacement between T1 and TC.
Why are they switched?
So this would be, okay, so let me use a little bit slightly different notation. I think this is going to make sense. So let's call this A, and call this B, and C is an element of AB. Right? So this is going to be where the velocity at C equals 0. So this is going to be S at C minus S at A. That would be the displacement between C and A, right? Plus the velocity at B minus the velocity at C. Or sorry, position at C. So this is the change in position from C to A. This is the change in position from sorry, from A to C, this is the change in position from C to B. Because C is between it. C is an element of it, so it has to be between it because it can't be A and it can't be B. So at that point, I then divide it up into two intervals, right? So if I had a number line here, and I had A, C, B, I find the displacement in this interval plus the displacement in this interval. To find displacement, I take the position at C minus the position at A. And then to find it here, I take the position at B minus the position at C.
So you're taking the one on the right of what you're finding and subtracting.
Yes.
That's why B is minus C. And
Yes.
C is minus B.
Yes. And that's the same thing here. That's why T1, S of T1 is minus S of T naught, because T1 is greater than T naught.
Okay.
Question?
It really matter which one is subtracted or absolute value.
It doesn't. It doesn't. You could flip them and not, and that's fine in the absolute value. What if it would be negative though? Let me think about this for a minute. So if I have 5 minus, let me just think, 5 minus a minus 3, that'd be 8. But if I have minus 3 minus 5, that'd be minus 8. Yeah. So no, it doesn't. I think with the absolute value. Okay. So it doesn't matter that order. Okay. So this is all to describe this particle. When's the particle's velocity positive? Well, you would check the velocity function and find out when the sign is positive. You would say, when is the acceleration positive? You would check the sign of the acceleration to see when is it positive. It might ask you, when is a particle speeding up? So when is it going faster, or when's it slowing down? When's it decelerating? So when's it accelerating? So when is it speeding up, and when is it slowing down? So decelerating. So I can speed up in one direction and then slow down in the same direction, but now I can also do that in the opposite direction. But you have to be careful because the velocity is going to be negative in the opposite direction. So it turns up to test if a particle is speeding up or slowing down. So we want to ask when a particle is speeding up and when is it slowing down. And it turns up a particle is speeding up when the velocity and acceleration have the same signs. So when acceleration is positive and velocity is positive, my particle is speeding up. When acceleration is negative and velocity is also negative, my particle is also speeding up, right? Negative, negative, or positive, positive. And then the particle is slowing down when velocity and acceleration have opposite signs. So let's look at an example, and let's go to Wiley for an example here. So speeding up and slowing down, straightforward there. So I don't know why I log on before class. Okay, this is 4.6. Let's look at this example. So this would be very similar to one that you would have on your exam coming up. I gave you a position versus time curve, and I asked you to find velocity and find acceleration. So what is the velocity function.
60 squared
Minus
36.
36t. What is the acceleration? 12t minus 36. Find the position, velocity, speed, and acceleration at each one of these times. What is the position at 1?
Minus 16.
So minus 16, right? So this would be minus 16. What is the velocity at 1? Minus 30. What is the speed at 1? 30, right? Because speed is the absolute value of velocity. And then what is the acceleration at 1?
24. Minus 24.
Minus 24. So what this means is the particle is at the position on the graph of minus 16 when time equals 1. The velocity is negative 30 feet per second. So it means it's going in a negative direction, and it's going that negative direction at 30 feet per second. And then the speed, obviously, is 30 feet per second, so that's how fast it's going. And the acceleration is minus 24. So it's accelerating minus 24 feet per second. So it's decreasing still, right? At what time is the particle stopped? That's when velocity equals 0. When is the particle stopped? At 0 and 6. Is it 6? Let me see. So if I factor out a 6t,
So you just set that equation equals 0 and you're finding 2 points, right?
I'm finding 2 points. So t
0 and
equals
6.
0, 0 and 6. So at 0 and 6. When is a particle speeding up? When's it slowing down? So I might want to write, what do we have here? This is 4, 6. This is number 17. I have a position function. The velocity function. The acceleration function. 15. So when is a particle speeding up or slowing down, I have to check the sign of velocity and acceleration. So when this equals 0, if I factor out a 6t, I'm left with t minus 6 equals 0. So if I look at the velocity function, if I look at 0 and if I look at 6, if I plug in, say I plug in 3, I get negative, right? So velocity is negative from 0 to 6, and then it's positive. If I set this equal to 0, and I factor out a 3, what would I have? Factor out a 12, and I have t minus 3, right? So the acceleration function, 0 to 3, I always kind of like to write these number lines right on top of each other, so then I can see, okay, what's the sign here, what's the sign here, what's the sign here. So if I plug in, this would be negative, this would be positive. So I can kind of see, if I break this up, so this would be negative as well.
And are you not testing below 0 because it says that the
T is greater than 0, yeah. So a lot of time with rectilinear motion, we're always looking at positive time. So I'm going to set this in motion, what's going to happen. So I would never talk about time equals negative 5. So here, when is the particle speeding up? When both the signs are the same, right? So it's from 0 to 3, and then 6 to infinity. And it's slowing down from 3 to 6. So putting that into Wiley, speeding up from 0 to 3 and t is greater than 6, and it's slowing down from,
Three or
0 to
six.
3.
yeah, sorry, I'll fix that, thank you, 0 to 3, 0 to 3, and when t is greater than 6, and slowing down from 3 is less than t is less than 6. Find the total distance traveled by the particle from the time t equals 0 to t equals 10. So we want total distance from t equals 0 to t equals 10. So I can't just plug in s of 10 minus s of 0 because I know the velocity at 6 equals 0. So I have to do what is the position of it at 6 minus the position at 0 plus the position at 10 minus the position at 6. So what would be the position at 6? What would be 2 times 6 cubed minus 18 times 6 squared? So this would be 6 squared times 2 times 6 minus 18. 12 minus 18 would be 6, so this would be 6 cubed. 6 cubed is 36 times 6. Okay, so you also can use your calculator, and so you don't make a stupid math error here. So 2 times 6, 2 times 6 times 6 was 72, and then 18, oh, I didn't do that right. 2 times 6 times 6 times 6, 18 times 6 times 6. So then I take this number minus this number. If I factor out as 6 squared, I'm left with this, which is definitely positive. So why would I get a negative here? It is negative. Okay, so that's 6 cubed, right?
What's that?
216, which is the same as what I got here. Okay, so this would be 216 plus s of 10 minus s of 6, and I know s of 6 is 216, so s of 10 would be 2. This would be 10 squared, which is 100, times 2 times 10, which is 20, minus 18, which is 2, so it would be 200. Does that, someone else get that? 200? 18 times 10, so this minus this is 200. So this is 200, so I should expect 416 to be my total distance traveled.
200 minus 216, that's the value of that.
Here?
Because don't you have to subtract S of 6 from S of 10? Because S of 10
Yes.
is 200, right?
Yes, it would be. Thank you. S of 10 is 200 minus 216, the absolute value of that. So I have 216 plus 16, which would be 232. 232. So if I just did S of 10 minus S of 0, I would have 200, which would not give me the right answer, right? So 232. 232. 232. The total distance traveled from 0 to 10, the total distance. So let's look at our algebra to see. We did position. S of 6. We got 216. S of 0 is 0, right? Clearly. S of 10 minus S of 6. Was this negative? This was negative 16. That was our problem. Okay, so this was 200 minus 216, the absolute value of that. So this should have been 216 plus 416. So that's 632. So this negative in here, right? So let's go back, repeat question. Is this, I don't think it's, so let's go ahead and do the distance here, because we don't have to go back and input everything, but I want to show you how the distance traveled, because honestly that's the most difficult thing in this section, is that total distance traveled. So given we're looking for the total distance traveled for the function t cubed minus 3t squared. This is the same one that we had in class, I think. And we want to see that from 0 to 5. So velocity. So the velocity function here would be 3t squared minus 6t. Set that equal to 0. Factor out a 3t, I'm left with a t minus 2. So at t equals 2 is within this interval. So the distance is going to be s of 2 minus s of 0 plus s of 5 minus s of 2. So what is s of 2? 2 cubed minus 3 times 2 squared. So 8 minus, so I have 8 minus 12 minus 0 plus s of 5, 125 minus 75, 25 times 3, 75, 125 minus 75 minus 8 minus 12. So this would be 4, right? So this would be minus 4 plus so yeah, 50, right? So 75 minus a minus 4. So this would be 4 plus 54. So 58. So I'm not going to put the rest of the stuff in, assuming we can do that right. So this would be 58. And that's right. So do you see how you have to be really careful? It's easy to make a mistake there with that negative and various different things there. You guys understand that? Okay. Now, of course, the derivatives can be more complicated than a polynomial, and you should be able to do that. So what would be the velocity function in this case? What's the derivative of 9? 0. What's the derivative of 9 cosine of pi t over 3? 9 sine of pi t divided by, oh, that actually doesn't matter. Pi t divided by 3 times the derivative of pi over 3, right? which would change this to 3 pi. Is everyone okay with that? So the 9 goes to 0, and then the chain rule here is the derivative of the outside value weighted to the inside times the derivative of the inside changes that. So that's the velocity function. What is the acceleration function going to be?
Wouldn't it be, squared?
It would be, thank you. Right? Because I have 3 pi out front, and I take the derivative of sine, which is cosine, evaluated to the inside, times 3, or so, times pi over 3. So the 3's cancel, and I have pi times pi, which is pi squared. So find the position function at 1. Well, when t equals 1, I'm finding 9 minus 9 cosine of pi over 3. So you're going to have cosine of pi over 3. So if I draw my triangle here, and I have pi over 3, this is a pi over 6, which would be 1, 2, square root of 3, and I'm looking for cosine, which is 1/2. So if you don't trust yourself to throw something out there, because you know it involves 1, 2, or square root of 3, draw a picture. It doesn't take that much more time, right? Your calculator can also evaluate it. Throw it in your calculator. Make sure you're in radians. So if you do throw it in your calculator and you get some crazy decimal, it's probably 1 over square root of 3, right? But, I mean, don't try to hold that decimal, too, because it says enter exact values here. So we got 1/2. So 9 minus 9 over 2 is 9 over 2. So 9 over 2. 9 minus 9 over 2. So cosine of this is 1/2. Okay. Velocity at 1. So when t equals 1, what's cosine of pi over 3? Square root of 3 over 2, right? Oh, sorry, 1 up more. So sine of pi over 3 is going to be 1/2. Wait, we had cosine of sine is square root of 3 over square root of 3 over 2, right? So I have 3 pi square root of 3 over 2. So it should be able to accept that. Do we think we have an issue?
No, but it's the wrong one for
The top one? I don't think so. What's cosine? Yeah, we did. That was 1/2, right? And sine was the square root of 3 over 2. So we have 3 pi square root of 3 over 2. Acceleration at 1 is going to be pi squared over 2. Oh, that's speed. Put that in the wrong one. What is the speed? Yeah. Is this positive? So the speed is the same thing as acceleration when it's positive. I don't know why it does that. 3 pi times the speed is the same thing as the velocity when they're both positive, when the velocity is positive. Sorry, I apologize for that. The acceleration we said was pi squared over 2. Pi squared. Thank you. Pi squared over 2. At what point is the particle stopped? Well, that's when velocity equals 0. Oh no, we're going to have to do trig. Right, so we're looking for when does 3 pi sine of pi over 3 t equals 0. Well, that's when sine of pi over 3 t equals 0. When does sine of an angle equal 0? 0 in pi and 2 pi and things like that, and multiple. So we have to check our interval here. What interval do I care about? 0 to 5.5. So 0's in there. Pi is in there. Is 2 pi in there? No. So 0 and pi are the only points in this interval, right? So I want to know, when does 3 pi over t equal 0? So when does pi over 3t equal 0, when t equals 0? And when does pi over 3t equal pi? When t is 3, right? So do you guys remember doing stuff like that in trig? So I want to solve for when this function equals 0. So I want to really focus on, because 3 pi never equals 0, so when does sine of an angle equal 0? Sine of an angle will equal 0 when that angle equals 0 or pi. So when the angle equals 0 when t equals 0, and the angle equals pi when t is 3. So the velocity is 0 at 0 and 3. So when is a particle speeding up or slowing down? So I need to look at the acceleration function. What do you get for acceleration? Pi squared. So this is my velocity. Acceleration was pi squared cosine of, and does that equal 0? I'm going to go ahead and make my number line. So if I want to make my number line for velocity, I have 0 and I have 3. So remember the graph of sine? Sine looks like this, right? It's positive, so this was pi. From 0 to pi, it's positive. And then from pi to 2 pi, it's negative. So the acceleration, when does cosine of 3 pi over 2 equal 0? When does cosine equal 0? When pi over 3t equals pi over 2 and anywhere else? Not in our interval, right? Because our interval is only from 0 to 5.5. So what is 3 pi over 2? 4.7. So that's in our interval. So we need to count that one as well. So here t would equal 3 over 2. And here t would equal, oh wait, no. This would be 3 over 2. This would be 9 over 2. So if I plug that in like a 0, this is 3. So 3 over 2 is going to be here. 9 over 2, that's greater than 3, right? Right. So this is 3 and this is 9 over 2. So cosine looks like this, right? So it's positive into pi over 2. So this would be positive, and then this would be negative, and then this would be positive. But I only want to go to 5.5, right? Was that what it wanted it to? 5.5. So I stop at 5.5. This goes here. This is 5.5. 2 pi would be greater than 6, right? So this would be 3 pi over 2 pi. So I believe this is, yeah, because this would be 2 pi, and this would be 2 pi. So I've accounted for everything. So when is it speeding up? Is that it?
Oh, no. 3 to 9.
And when is it slowing down? from 3 over 2 to 3, and then 9.2 to 5.5. So putting that in, speeding up from 0 to 3 over 2. I wonder if I can put it in like that, or if it wants it as 1.5. And 3 to 9 over 2. Slowing down from 3 over 2 to 3, and then 9 over 2 to 5.5. Find the total distance traveled. So from 0 to 5. Do I have any zeros from 0 to 5? Pi, right? Pi is in there. So I'm looking at the total displacement from 0, or the total distance. Go ahead on the next page. I have distance given the position function. What was the position function? Since I didn't write a lot of these down. 9 minus 9 cosine of pi over 3t from 0 to 5, but I have to stop at pi. Oh, 5.5. Oh, no, that's fine. That's 0 to 5. So I need to find what is the position at 5 minus the position at pi plus the position, oh, it doesn't matter the order I do it, I guess. Pi minus the position at 0. So I switched them, right? This would be the first interval and this would be the second interval, but that's fine since I'm adding them.
I thought it equals 0 at 3.
Yeah, the velocity equals 0. Where did we say the velocity equals 0? At t equals 3, you're right. Sorry, at 3, not pi. I wrote that wrong. Stop at t equals 3. So this would be, let me just write this the other way. So this would be s of 3 minus s of 0 plus s of 5 minus s of 3. What is s of 3? So what is cosine of pi? Cosine of pi is minus 1. So I'd have 9 plus 9. So it's 18. Minus at 0, cosine of 0 is 1. So I have 0 here. Plus at 5 pi over 3. Okay, so 5 pi over 3 would be pi over 3 short of 2 pi. So that's this quadrant here with a reference angle of pi over 3. Because 6 pi over 3 would be 2 pi, right? So that's pi over 3 short of 2 pi. So pi over 3 here, this would be square root of 3. And this would be 1, but this would be negative. So cosine of 5 pi over 3, this reference angle, cosine would be 1/2. So you can also say all students take calculus, cosine is positive here, so I get 1/2, so I get 9 over 2. Minus at 3 would be 18, so here I'd have 18 plus, what would this be, 9 over 2 minus 18, so 4.5 minus 18, what would it be? So 18 minus 27 over 2, or
That's what we asked you about.
no,
27 over 2.
27 over 2, so 18 minus 27 over 2, so 27 over 2, so 27 over 2 plus 18 So 23.5. Oh, that's 10. 18 plus 27 over 2 would be 31.5. So if you stay with me, see if all this is right. What did we get? Look out, 31.5. Yay. All right, well, thanks for sticking with me. I'll see you guys on Monday.